Baxter is a robot that can work alongside humans. It's very safe. As you can see, there's not a cage around it. And one of the other nice things about Baxter is that because it's two different arms, it could be doing two different things at exactly the same time. So in this case, as you can see, it's picking up cups in different orientations from different colors, and it's going to put them in that tray. At the same time, it's picking up these electrical boxes and putting them in parallel in a pattern that I've defined. The nice thing about Baxter is that the parts don't always have to be in the same location. They can actually be in any orientation, and Baxter is smart enough to figure out how it needs to pick up the part and then locate it the way I need it. Talking about safety, one of the nice things about Baxter is that I can be in the way because I'm, a clumsy human and I don't know that Baxter is going to get in the way. And as it bumps into me, we get some visual feedback that I am in the way, and it just gives me a little bit of a nudge, and it keeps working.
This is the Form 1, is our first product. It's a desktop stereolithography 3D printer. It's high resolution for only $3,300 on your desktop. We have minimum feature size of 300 microns and a layer thickness of only 25 microns in a build volume. It's about 5 by 5 by 6.5 inches. So this is an amazing tool for engineers, product designers to have on your desk to be iterating quickly and to be designing 3D parts and printing. Here we have some quite high resolution jaw model, but you can also print parts and anything you're designing for developing a product. Design it in CAD, put it into our software, print it the next day or later that day, a few hours even, you'll have your part.
What the Delta handheld XRF will do is to identify if there are contaminant metals or elements in solder. So for the big RoHS regulation coming up next year for medical devices, this will detect the presence or non-presence of lead in the solder. To use the Delta handheld XRF, you simply take a sample, and in this environment here, we have a PCB board, and what we want to do is check any metal contaminants in the solder. So you would take the sample, point it at the sample, analyze, and get your results. And what a lot of companies like to do is print out a report, which will show your results, what elements, how much of each element, a picture of whatever you're testing, and the spectra.
IGUS is a manufacturer out of Cologne, Germany, and we make products that help machines in their automation and movement and motion. We make chains that control cables and wires. We have Drylin slides, we have bearings. We work in the robotics industry and help the 6- and 7-axis robots manage the cables, hoses, and wires that keep the robots doing the jobs that they need to do.
So what we have here is our Object 30 desktop machine. Our 3D printing is taking liquid photopolymer and we are jetting it into pixels, the exact geometry of your designs, if you will. And what basically that's doing is it's filling in wherever there's open geometries in your design with support material. From there, you're getting your models that are going to be basically on this particular tray anywhere from 12 by 8 to 6 inches tall. It's curing as it's rolling back and forth with UV. So that's what's giving you an acrylic part when it's done. The parts come right off the tray. You can pull off a lot of support material on its own and then spray it down on our water jet when they're done. So it's a quick, efficient way to get modeling. Now basically you're taking any 3D drawing, as you will. You take the 3D model, convert it to an STL file, import it into Object Studio, which is a rendering software, and basically position it on your part however you want, and basically gives you the best accurate way of building the part as far as resin consumption and time to build. And when you're done, you have kind of finished very high-end detailed parts using anywhere from 16 to 28 micron layer thickness, so about 1/2 mil to 1 mil, depending on the machines that you're using, and gives you extremely accurate, high tolerances, plus or minus 2 to 4 thousandths on a part.